So here we have another rational inequality that we're asked to solve. But before we can go ahead and get the critical values, we need to put everything on one side. So we want one side to have 0, so this 3 here can group over here. Good, so we subtract 3 from both sides. So we group this 3, it become minus 3. Now, 3 is 3 over 1, agree? Now, aim here, we want to, before we can subtract these two fractions, we need to have a common denominator. Good, so we need this denominator to be the same as this denominator here. So we can multiply this denominator here by x minus 2. And for the fraction to remain equivalent, we need to do the same thing to the numerator. Good? And then we have a common denominator now, x minus 2, so we can put everything over x minus 2. And we can combine the numerators now, so here is 4x plus 1. And then this other numerator here, we notice we have minus 3 outside. So we expand in the bracket, it's minus 3 times x, that's minus 3x. And minus 3 times minus 2, that's positive 6, less than 0. So now we can group like terms. Let me just separate this. So if we group like terms, here we have x minus 2 less than 0. If I group like terms, the x's, I have 4x minus 3x, that's 1x. And I group the constants, 1 plus 6, that's 7. And then the critical values are the values which make the numerator 0, that's negative 7, and the value of x that will make the denominator 0, which is 2. In other words, if you plug 2 into this denominator here, you get 2 minus 2, which is 0, right? And if you plug negative 7 into the numerator, you get negative 7 plus 7, which is also 0. Or you could just get it by equating the numerator to 0, x plus 7 equals 0, x equals negative 7. Equate x minus 2 equals 0, x equal to 2. So these are our critical values. And the solution set now, because it's less than, because we're doing a less than situation here, the x value will lie between the two critical values. So it's less than the smaller value, but greater than the larger value. In other words, any value of x that's between 2 and negative 7 will make this entire expression less than 0 or negative. Let's try a value. What value lies between 2 and negative 7? 1, the number 1. So if I plug 1 into this, I will get 1 plus 7, which is 8. I get 1 plus 7, which is 8. And in the numerator, in the denominator, I will get 1 minus 2, which is negative 1. What's 8 divided by negative 1? Negative 8. Is negative 8 less than 0? Yes, it is. Good. So any value between 2 and negative 7 will satisfy this inequality. Which means, therefore, that if this was a problem, let's say this was a problem, let's say the problem was separated. Let's say the question was, you're asked to solve 4x plus 1 over x minus 2 greater than 3. Same problem, but it's just that the symbol in the other direction. The critical values will be the same, but the solution set, because it's a greater than situation here, the solution set is x would be greater than the higher value, but less than the smaller value. In other words, any value that's greater than 2 would satisfy this inequality, and any value that's less than negative 7 would satisfy this inequality. Also, as we did in the previous video, we could have times both sides by the square of the denominator. Let me just. Could have times both sides by the square of the denominator the square of the denominator, what is it? X minus 2 all square. I could times this side also by the square of the denominator, x minus 2 all square. And what will happen is that we'll have 4x plus 1, x minus 2 into x minus 2 square give you x minus 2, less than 3 x minus 2 all square. And remember, we'd have to bring everything over on one side, so bring this over. We'll have it's 4x plus 1, x minus 2, and this term group over here would have negative 3 x minus 2 all square. Notice x minus 2 is a common factor, and since x minus 2 is a common factor, we can factor out the x minus 2, and if we factor x minus 2, we factor out x minus 2 from this term here, we end up with what? 4x plus 1. And if we factor x minus 2 from this term here, we're left with another x minus 2. So we're left with minus 3 in the bracket. We're left with minus 3 in the bracket. Minus 3 outside there, and then you still would have x minus 2 there, right? So we can just expand the bracket in one group. We just separate, just to. So first bracket here, we have x minus 2. In this bracket here now, we would have 4x plus 1. And here, we have expand this, we have minus 3x. And negative 3 times negative 2, that's positive 6. Less than 0. So we end up with x minus 2. And the group here would have group the like terms. 4x take away 3x, that's 1x. And 1 plus 6, that's 7. So the critical values, to get the critical values, you equate both brackets to 0. And solve. So the critical values are the value that makes the bracket 0. So positive 2 and minus 7. And of course, the solution is because it's less than, x would lie between these two values. So less than the higher value, greater than the smaller value. And if it was greater than, then x would be greater than this larger value. For example, if this was a problem, as we discussed earlier, the solution set would be x would be greater than the larger value, and x would be less than the smaller value, the smaller critical value. Well, the larger critical value was positive 2, right? And the smaller value, negative 7. Good. So any of those methods works just fine.